In the vastness of the universe, every star, every planet, tells its own story. Curiosity about this infinite world drives us to go further and see deeper. Today, let's take a look back at the mind-blowing discoveries in astronomy that not only changed our understanding of the universe, but redefined our place in it. Welcome to World Wonder. Today, we're revealing the 10 most shocking discoveries in astronomy. These discoveries opened a new chapter and led us into the unknown. Let's unravel the mysteries of the universe one step at a time. No 10 cosmic microwave background radiation. With only very small variations, the universe is filled with a uniform form of radiation, known as cosmic microwave background radiation, which was discovered quite by accident by two Bell telephone employees while they were working on satellite communication experiments. The implications are profound, since the uniformity of the radiation seems to confirm the notion that the universe originated in a single event from which everything else flows, such as the rapid and accelerated expansion of the universe. Moreover, if the fact that on really large scales, all visible and detectable matter in the universe is distributed almost evenly and uniformly is taken into account, it could mean that the Big Bang did in fact occur, although proving this is another matter entirely. No, 9 dark energy. Since the exact mechanism, or even driving forces behind the acceleration of the rate of expansion of the universe is unknown, the existence of a form of energy, dubbed dark energy, has been proposed. However, the discovery has less to do with the nature or even existence of this energy than it has to do with the fact that the universe has been discovered to be expanding at an ever-increasing rate. The nature of the proposed dark energy is still unexplored and the cause of heated debate in cosmological circles, but it is conceivable that it is a property of space-time, as opposed to a form of energy. For the moment, though, dark energy accounts for an astounding 74% of all the energy in the universe, which means that at best we have only a 26% understanding of how the universe works. No, 8 dark matter. Another major discovery is that of dark matter, which seems to dictate the gravitational effects within galaxies. At the heart of the matter is the fact that the observed velocity of some stars within galaxies, as they orbit the cores of galaxies, differ wildly from what calculated values should be. The problem is that much of any given galactic disk rotates around the core at the same velocity, which according to calculations based on known gravitational values is clearly impossible, given the fact that the outer stars are much further removed from the core and should thus orbit the core more slowly than stars that are closer to the core. From appearances, it would seem that galaxies are entirely embedded in a form of matter that is currently unknown, undetectable, and likely to remain so for the foreseeable future. Nonetheless, the existence of this form of matter is the only explanation for the observed behavior of galaxies, unless there are some undiscovered properties of gravity that still elude science. No, 7 exoplanets. There was a time when the mere idea of planets existing outside of our own solar system was considered to be scientific heresy. But the discovery by Dr. Alexander Wolszczyn of the first such planet, 51 Pegasi b in 1992, had the effect of changing how astronomers look at the universe, and especially at how stars form. Although most exoplanets have many times the mass of Jupiter, and are therefore called hot Jupiters because they orbit very close to their parent stars, improved technologies and techniques have made it possible to discover ever smaller planets, some of which orbit stars not unlike our Sun. Today, there are more than 5,000 exoplanets known, which disproves the erstwhile scientific doctrine that planets are the exception rather than the rule. No, 6 black holes. Long suspected to exist, but only proven through the work of physicist Stephen Hawking, black holes are the invisible remains of massive stars that have collapsed under their own gravity. Since stars exist only because of the equilibrium between their own gravity and the outward pushing pressure of the nuclear furnaces in their cores, a massive star can contract to the point of invisibility if the outward pressure ceases to counteract gravity. Moreover, since light consists of matter that has mass, the enormous gravitational field of a black hole prevents photons from escaping, which makes it impossible to detect a black hole in optical light. the enormous gravitational forces involved when a black hole swallows an object, such as a star, tear the star apart when it crosses the event horizon, which is a theoretical limit around a black hole beyond which escape is impossible once an object crosses it. The destruction of the object releases huge amounts of X-rays and other radiation, which reveals the location or presence of a black hole. Recent research has shown that all galaxies with a central bulge contain a black hole, some of which have millions and even billions of solar masses, and that there exists a close correlation between the mass of the central bulge in galaxies and the mass of the black hole it contains. 5. General relativity. Among other things, Einstein's theory of general relativity predicted that since mass and energy are essentially the same, light that passes by a massive object would be bent by the gravity of the massive object. Although the mechanisms are different, the principle can be demonstrated by viewing a drinking straw in a glass containing water. The straw seems to bend where it enters the water. This is roughly analogous to the displacement of objects by the deflection of light as it passes massive objects. This was proven to be the case when observers noted that the planet Mercury was out of place and not where it was supposed to be relative to the Sun at certain times. British physicist Alfred Eddington proved that it was caused by the deflection of light by the Sun when he measured the displacement of background stars relative to the Sun during a total solar eclipse. Further proof of this is the existence of Einstein circles, which is the distorted images of less massive galaxies behind more massive structures between Earth and the objects whose light is being distorted as it passes by the more massive intervening structure. 4. Redshifting of objects in the universe. With the discovery of Cepheid variable stars nearly 100 years ago, it became possible for Edwin Hubble to prove that the Milky Way was just one of billions of galaxies in the universe. This discovery led to ways of measuring the speed at which some of these galaxies are either approaching us or receding from us. By comparing the light spectrum of an object with that of a stationary object, it is possible to measure the amount of red shift of the spectrum, which is the displacement of the entire spectrum toward the red, longer wavelength part of the electromagnetic spectrum. The amount of displacement is tiny to be sure, but the amount of shift is directly related to the velocity of the receding object. Thus, the higher the red shift, the farther the object is away from us. The distance is also directly related to the velocity of the object, which means that in practical terms, the further away an object is, the faster it is receding. The operating principle here is the fact that as an object recedes, the light from it is stretched. Similarly, the light from an object that approaches us is compressed, thus moving the entire spectrum of such an object toward the blue, shorter wavelength part of the EM spectrum. That is how we know that M31, or the Andromeda Galaxy, which is our closest big neighbor, is approaching us at a velocity of 250,000 mph, with the collision expected in about 4 billion years. 3 gamma-ray bursts. Long a mystery, the massive bursts of gamma rays that reach Earth from all points in the sky are now known to be the result of the biggest explosions in the universe, when massive stars explode in titanic detonations that are so energetic that they can outshine their entire host galaxies for several months. The resulting dispersion of stellar matter forms intricate formations of gas and dust, such as the beautiful Crab Nebula. This nebula is still expanding as the result of the explosion that destroyed a massive star in about the year 1054. Gamma-ray bursts can also occur when a neutron star, which is the remains of a previous stellar explosion, detonates due to the accretion of matter from a companion star in a close binary system. 2. Age of the universe. Although the use of redshift measurements was instrumental in determining the age of the universe, the first attempts fixed the age of the universe at only about half of the modern accepted value, which is 13.75 billion years. The problem involved the fact that the wrong class of Cepheid variable stars was used in the calculation that was made in the mid-1920 ES, and that the rate of the expansion of the universe was based on incorrect assumptions. It was only several decades later, with the discovery of a second class of Cepheid star, which had twice the period of the first, and thus a different relationship between luminosity and distance, that astronomers reapplied the original calculation but with different values. The result was in perfect agreement with geological evidence for the age of the Earth, and by extension, the universe. No, one Big Bang and inflationary theory. Although the origin of the universe is untraceable, the Big Bang theory is still best at explaining it. Recent advances in cosmology seem to confirm that the universe originated in a single, infinitely dense and infinitely massive singularity, which is the word used to describe that which cannot be described. The observed and uniform expansion of the universe can now be traced back to a single point in time, but beyond that, the laws of physics as we know and understand them no longer apply. The tentative confirmation of the Big Bang theory can be seen as a discovery of sorts, but much uncertainty remains, and it is almost certain that the origin of the universe will never be known with any degree of accuracy or certainty. Each discovery is like a secret that the universe reveals to us, leading us to a deeper understanding of this magnificent universe. Our journey is far from over, and there are countless wonders waiting to be discovered in the future. If you are passionate about the mysteries of the universe and scientific exploration, don't forget to subscribe to our channel. Leave your thoughts in the comments section below. We will continue to walk with you on this scientific journey to explore more amazing secrets of the universe.